Active safety, as well as the entire automotive industry, is going through a digital transformation. New active safety systems can handle more and more complex scenarios, but when you think about fully autonomous driving vehicles, the complexity is quite exploding. So traditional testing approaches need to be complemented by simulations which are running massive scales of virtual scenarios. This, on the one hand, helps of course optimizing the testing on the proving ground, which is based on smart virtual analytics. But on the other hand, physical testing on the proving ground is needed to verify and to validate simulation models. So we see simulation and proving ground testing will go hand in hand in the future.
Scenario generation and analysis are key components in handling the complexity and scale needed for AD and ADAS product development, verification, and validation. The needs are vast to productively handle millions of different tests needed, expose the edge cases and unknown unknowns, effectively check for completeness of your verification, have the ability to communicate the results with external bodies such as regulators, compliance companies, and of course correlate between real life and virtual testing. So how do you do proper scenario management and analysis? For that, Fortelix has developed Fortify, a powerful testing tool and agnostic platform that can connect to any simulator, hill, test driving log, and proving ground robot. Generate and analyze the scenarios needed to ensure safety and productivity of your ADAS and AD. Fortify uses MSDL, which is an open source language to describe scenarios, which serves as the guiding example language to the global standard OpenScenario 2.0. Using MSDL, our customers can easily create millions of meaningful scenarios and edge cases in the virtual world. Imagine a simple cut-in scenario in which a car cuts in front of the device under test. How many different cut-ins can occur? I mean, a cut-in from the left, from the right, a cut-in on a 6-lane road, on a 2-lane road, in different weather conditions, different angles of entrance to the lane, and so on. All of these will be automatically generated from one short and concise scenario description in MSDL. After we run the scenarios on the different simulators, a proper verification and validation process would require us to perform some of the tests on the proving ground to correlate between the virtual and real-world data. Fortify allows the generation of scenarios that can work across testing platforms, including proving ground robots, and to demonstrate this capability, we have partnered with Humanetics.
This need of simulation validation was communicated to us by many of our customers. They asked us to come up with a solution to allow the connection between the virtual simulation world with the physical testing world on the proving ground. So we opened our system and developed the UFO base script, an easy-to-use, clear text language which allows the third parties to export the simulated scenarios into our testing system. So now our driving robot and all our UFO models can reproduce the simulation on the proving ground under real-world conditions. This, of course, allows a perfect validation of the simulation software to make sure that also all other simulated scenarios have a perfect correlation to the real world.
With our partners Humanetics, their highly sophisticated robots and operation software, we were able to generate scenarios using Fortify and run some of the selected tests on the proving ground. MSDL allows the generation of both very abstract scenarios that fit massive scale generation in the virtual world and directed scenarios that are very concrete to run on the proving ground. The analysis of test coverage and KPIs is done using Fortify Manager. Fortify Manager collects both real-world data from the proving ground scenarios and the virtually simulated scenarios as well. It aggregates the coverage information and helps intelligently direct the verification and validation efforts towards completion. It does it in an iterative manner. In our cut-in example, an analysis suggests we have fixed a planning error in the device under test that was exposed during virtual testing in a massive scale. After running the scenario on the proving ground, we have verified that the bug was actually fixed. Now we would like to make sure that the fix is applicable for all the surrounding cut-ins. For that, we will generate thousands and hundreds of thousands of concrete cut-ins around the bug using MSDL constraints and run them in the virtual environment. After we will finish that, we will continue to look for coverage holes.
With this new software option, tested for the first time together with our partner Fortelix, Humanetics is now enabling to connect the virtual world of testing with the physical world of testing, also for active safety, which allows now a continuous testing chain so the development towards autonomous driving can further accelerate.